So in this video, we'll be seeing about aligned and unaligned addresses. So let us see what is actually an aligned or unaligned address. So let us take an example of say the address 1004,000, let us say, and the size is like around 4 bytes. So what we need to see is like express this 4 as a power of 2. So this is 2 square. So what effectively is the LSB 2 bits of the address must be 0. So if we see this hexadecimal address 1000, so this is 0. So effectively this is 0, 0, 0, 0. These are the LSB 4 bits, and we see that the LSB 2 bits are 0. So this address is aligned to the size of 4 bytes. So this address is an aligned address when size is 4 bytes. So this is the concept of aligned and unaligned address. Let us explore further on the same. So an address is aligned if to the AW size, the lower AW size bits of the address are 0. So as we just saw that the 2 square, the 2 bits of the LSB 2 bits of the address needs to be 0 for the address to be aligned to the particular AW size. So because the reason is the transfer size is nothing but 2 power AW size bytes. So let us try to check. So if in case AW size is equal to 2 and the address given is 1004 in hexadecimal, we see that AW size is 2 and the transfer size is 4 bytes. And when we check the address 1004, so the 4 is actually 0, 1, 0, 0. So we see here that the lower 2 LSB bits of the address is 0. Hence, this address is aligned to the size of AW size 2, which is equal to 4 bytes. So let us say that the same address, in case the AW size is 3, we clearly see that the third LSB bit is not actually 0, it is 1. So clearly this is not an aligned address, it is an unaligned address. Now let us take the address 1010 and the size to be 4. So we see that the LSB of the AXI is 0, so which is effectively 0, 0, 0, 0. So in this case, LSB 4 bits are 0. So indeed this particular address is aligned to the AW size equal to 4. Now let us take the next scenario, where the AXI data bus is 64 bits, but we are just sending AW size equal to 2, which is effectively 4 bytes, and the address is 1006. So we need to, so this clearly we can see that also it is 64 bits, we are just sending 4 into 8, which is 32 bits. So it is clearly an error transfer scenario. We need to see if this is a kind of valid scenario, right? So 1006. So we see that this is 6. So 0, 1, 1, 0. So basically we are trying to see the LSP 2 bits. So this is actually unaligned to the address size of 2. So clearly this 4 byte alignment required lower 2 bits is not exactly 0. So this is an unaligned narrow transfer. So I can just try to put a small example of the same. So let us just take the AW length is like 3, which is equal to like 4 beats of transaction. So the same, this is like 64 bits. So 3, 4, 5. We just number this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let us just check these addresses now. So we see that the address which is given is like, let us say, 1006, or let us say this is the 1006, right? Let us say, for example. So it is starting from here. So this basically, so you see that these are all not used. So this is how it kind of gets used. So in the first cycle, these 2 bytes actually gets you 6 and 7 is goes in the first transfer. The next transfer, this is the second clock cycle or the second beat. We see that these 4 bytes get used, and in the third clock cycle, these let's take these four bytes of data gets taken, and in the next one these 4 bytes of get taken. But in the very first beat we see that since the address is an unaligned address, so it starts from 6 and 7. Only these two uh, bytes of data is taken in the first beat. So it's very much a case of an unaligned narrow transfer scenario. So we need to give the W strokes appropriately. The master needs to give the W stroke appropriately for this transfer to take place. So this is about this question. We'll further move on to the next query here. So let us say if the AXI data bus is 128-bit wide, does the address need to be aligned to 16 bytes? So here what is given is the data bus width, but the AW size need not be 128-bit wide. It can be lesser this as well, in which case it's a narrow transfer. So this need not be the case, right? So the same thing is explained here. Alignment is based on the AW size and not the data bus width, not the bus width here. So in case the AW size is 2, only 4 byte alignment is needed and not 16-byte alignment. So next we see that AW size is 3 and the address is this. So we kind of see that this kind of is a tricky question. We need to see the what is the radius given here. It is actually a binary. So we need to see that the let's be 3 bits, right? So whether it needs to be 0. So here in case of this, yeah, even if it would have been X, I think it would have not mattered. But we need to be careful about this, and so that we kind of don't answer the question wrongly. So here we see that the AW size is 3 and the LSB 3 bits are zeros. So this is an aligned address. Next we see that the AW size is 2 and AW length is 3 and address is 1008. Is this aligned for a wrap bus? This is the query. So first we need to calculate the wrap size, which is nothing but AW length plus 1 into 2 per AW size. So which is like, this is 4 into 4 bytes, which is 16 bytes. It is equal to 16 bytes. So AW size is 4 bytes, so this is equal to 16 bytes, right? So we need to see it is aligned to the 16 bytes or not. 1008. So 8 if you take is 1000, but 2 power 16 is 2 power 4. So ideally the LSB 4 bits needs to be 0, but in this case the uh, LSB 4th bit is actually a 1. So this is not aligned to this 16 bytes address. So it is not wrap aligned to this boundary. So next question is AW size is 2 and the address is 1006 and AW bus is fixed. So is this allowed or not? So let us see, because the fixed bus does not remove the alignment rules. AW size alignment is always required. So here we see that it is actually 6. So which is effectively 0, 1, 1, 0 and AW size is 2. So this effectively means, all the this we all the burst will be always unaligned address. So this should not be this will not be allowed in this case of fixed burst. So if we take the same thing, right, AW size is 4 bytes, so it will be this way: 0, 1, 2, 3, 4, 5, 6. So we just, like, let us say this is a 0 offset, so maybe it is offsetted as 1000. This is kind of 1000, so this becomes like 1006 effectively. So always the address kind of is at 6 and 7 only. So effectively, although, right, we want 4 bytes of data, we are actually only sending 2 bytes of data in every transfer. So this is not a valid scenario, and it does not allow the case of unaligned address. Fixed bus does not allow the unaligned address. So the next question is like AW size is equal to 1, which addresses are aligned? So AW size is equal to 1 effectively means 2 power 1, which is equal to 2 bytes. So in case of this, the 1000, so effectively just one bit needs to be 0 here, right? So this 1000 is an aligned address, 1002 is an aligned address, because it's 10, effectively it's 0010. So every even address is an aligned address, and every odd address is an unaligned address in this case. So how do you quickly check the AXI address alignment? We check the lower AW size bits of the address are 0, since AW size defines the transverse size, which is nothing but 2 power AW size bytes. So effectively, this 2 power AW size bytes is a total transverse size, and this AW size, whatever that is given. So those many bits of LSB needs to be 0 for the address needs to be aligned. So this is what about the aligned and unaligned address. Hope it was clear here. Thank you.